global information and communication platform with tremendous computing power, perhaps even more computing power than any other thing that touches your life. Today we're seeing the creation of a brand new DNA for the automobile.
By the time of 2030, we'll have had a paradigm shift in the entire construction of the automobile.
I know that we are witnessing a convergence of revolutionary technologies.
Look down the highway and you'll see the information automatrix. The interconnection of computers, roadways, people, and cars. Highways without speed limits. Twice as many cars. Computers on wheels. How they will think and how they are fueled will challenge everything you believe a car to be. This is Future Car. It's closer than you think. The computing power of cars will be almost unlimited. As digital power increases, so will our safety. So will our productivity. So will our quality of life. We won't have to drive our cars. Someday, they will be driving us.
The information processing capability of an automobile is very impressive today and is going to become extraordinarily more impressive in the future.
The application of nanotechnology, artificial intelligence, microsensor technology will shake everything up concerning our car.
It knows where you are. It knows where you're going. It knows what you want to do.
I'm always enchanted by truly autonomous machines that sense and think and act for themselves. Humans might see oncoming traffic from the side, but wouldn't measure the approach or the distance or the speed in the way that sensors could.
So in 10 or 15 years, we expect the cars will be able to drive through your neighborhood and understand the difference between a ball or a child and other cars on the road and be able to stop and be as safe as a person driving, maybe even safer.
Red Whitaker and Chris Urmson of Carnegie Mellon University believe in the future of self-driving vehicles. So they have taken up the DARPA Autonomous Vehicle Challenge, a competition sponsored by the Defense Department with the aim of sending unmanned vehicles into enemy territory. The results of which will affect how every one of us will be driven in the future.
The screen here is control we have to turn the vehicle basically into a robot. It allows us to electronically control the steering and the indicator lighting, and it's the interface between the car and the computers. If we were to sit here while the robot was driving, we'd see the steering wheel move, we'd see the pedals move. It would be like there was an invisible person driving.
The Carnegie Mellon car is no different from what you drive now, except that your SUV doesn't have 10 Core 2 Duo computers, each sporting a gig of memory.
We take the camera and the laser data and we feed that to the computers, where we have some algorithms that interpret the images from the camera and the shape of the ground from the lasers, and they figure out where the road is. And from that, the robot will send an electrical signal up to a controller, which will turn the motors to steer the vehicle and press the brake and the throttle to keep it moving at the right speed.
It's one thing to talk about autonomous driving in theory, but what will it take for computer-driven cars to truly gain widespread acceptance?
In automation, performance is only a small part. Reliability is everything. To be accepted and used, the technology has to be rock solid. As a developer of autonomous driving machines, I am perfectly comfortable being driven by a computer. To get this far, this fast with computing opens a huge future possibility.
The day is coming when your car will be the most powerful computer you own. It will have a brain 10,000 times faster than yours. connected to you. And then, technology will plug you into the auto matrix. The car, the machine, will think, act, and drive. The day is coming. But before there will ever be an auto matrix, before our cars will change the future of driving, we must look back to a man named Gordon Moore. In 1965, Gordon Moore, co-founder of Intel, observed that the complexity of integrated circuits with respect to minimum component cost doubles every 24 months. Translation: computers get twice as smart about every 2 years.
Think of a birthday card that you get in the mail that sings happy birthday to you. There's a chip in that birthday card that has more computer power than all the Allied forces of 1945. And what do you do with it? You throw it away in the garbage. That's Moore's Law.
By 2030, computers and cars will have more than 3,000 times the processing power they have today.
Chips then will cost about a penny. So in other words, chips will be embedded by the billions in the roads, inside the car, everywhere around us. My name is Michio Kaku, and this is my testimony about the future. Computation will be everywhere, almost like electricity. Electricity today, we don't even think about it. Now, with computer power doubling every 18 months, the car is the next place to be totally revolutionized.
But can all this technology make us better drivers?
Wouldn't it be nicer to have a computer that senses the rhythms of your body so that when you doze off, it'll wake you up? Think of how many lives such a simple device could save.
The first step towards ultimate safety in future cars can be seen in Switzerland and the world's most sensuous car.
The sensor tries to influence the driver to be relaxed, to be attentive, and make him safer this way. The idea behind the sensor is really to get to the cause of the accident. The cause of the accident is the human being.
A biometric watch measures the driver's pulse. A mobile eye camera records his lane change behavior, as well as how close and at what speed he approaches cars ahead of him. An onboard computer uses special algorithms to evaluate the driver's current state of mind, and if necessary, it steps in to change things.
If you should be starting to fall asleep, you start to hear a generic sound which stimulates you. If you should be aggressive, you get to hear more chill-out type music, lounge music, to calm you down, to feel relaxed.
A driver's emotional state is also affected by light. So Frank equips the cabin with color-changing crystal and tiles.
The changing of color is done by a thin crystalline film which changes the voltage and the polarization of the power to the film. The normal color, while everything is okay, is green. If you should be aggressive, if you should need to cool down, I think there's only one color which can do that, which is a blue.
If a car's interior can change with your mood, why not the drive quality?
We are on the brink of changing and rewiring, rewriting the DNA of the car. From the old mechanical internal combustion mode to a new hydrogen, electric, digital-based car.
As the electronic brains in cars get smarter, mechanical connections for steering, braking, and accelerating will give way to digital controls with lightning-fast response like a video game. It's called drive-by-wire, and with it, your car handles and responds exactly the way you want it to.
For example, brake-by-wire allows the vehicle to stop sooner than conventional hydraulic brakes do. It's like turning on a light switch and the light comes on immediately.
The thing that helps you get emotionally attached to your car is actually going to be delivered via software. The chassis dynamics, the way that the vehicle moves up and down when it goes over bumps, also can be controlled dynamically, and even the traction and the torque at each wheel.
And if your mood changes, your car can change right along with you.
You know, the auto industry is as much an entertainment industry and a fashion industry as it is a transportation industry.
You'll be able to download performance profiles for your car the way you get ringtones for your cell phone.
Custom software is one more step towards a future when cars will do everything for us. And while that day is not here yet, young car designers like Matt Zoller of GM's Design Internship Program are already there.
I love the idea of being able to break the mold, to create something new, something different, and be able to bring that to other people.
His digital dream for the future, a concept he calls the overstimulation car.
It's a one-seat car that totally consumes this person and creates a virtual mobile world for them to ride around in. There'd be holographic imagery. You have menus scrolling. So you're in the world and you're experiencing it, but you're experiencing it in the way that you want to through this virtual driving, and really get a feel for like this online community of cars that are driving down the road.
Cars will become members in a worldwide network.
It's almost like an auto matrix in terms of the connectivity of the automobile with our everyday lives and everything that we're doing.
Cars locating wireless internet signals will require vehicle antennas that work consistently, perfectly. Whether it's satellite radio, GPS, or onboard wired and wireless systems, it's all part of the auto matrix. And the need to be precise with RF, or radio frequency wave testing, is critical.
This is the world's first vehicle-size, electronically modulated, spherical near-field antenna test system. Part of our job is to make sure that the antennas that we put on the car work as well as they can, and to make sure that when we put on different types of antennas that they don't start fighting amongst each other.
When your car operates in the digital realm, crossing the wrong signals can be devastating. At best, you might lose your onboard email connection or just get hopelessly lost. At worst, cars might literally end up driving blind. That's why Jana Lee Graham spends so much time testing RF signals.
When you look at our arch, we have 103 probes, and what they are doing is transmitting and receiving signals at all different elevation angles, just as if the vehicle was going up and down hills, or depending on what angle you are in response to the transmitting antenna.
So radio frequency, or RF communication, is always smooth.
The reason why we spin the turntable is to measure a second antenna parameter, and that is directionality. We would like all of our antennas to have a circular performance, so no matter what way you're driving, you can receive weak RF signals. Once we've completed an entire rotation of the turntable, we've then generated something that we call near-field data. This is in contrast to what would happen in the real world, where we'd have a satellite miles away from the vehicle.
Jana Lee takes her near-field antenna results and mathematically extrapolates real-world information, hoping for a high level of gain.
The higher the gain, the better the antenna is at measuring weak signals.
And why is this important?
It's hard to know what frequencies future systems are going to come online. The RF spectrum, when you look at it, is getting very full. I think you're going to see more and more electronics on the vehicle be RF driven. And who knows, eventually we may get to the point where we no longer even need to have wires inside the car. Maybe I'll be transmitting either fiber optics or through RF links.
The wireless car, built with micro-technology, providing the digital power to create the auto matrix. Circuitry so small, it's built on top of individual atoms and molecules.
We think of doing things based on molecules where each bit of information is based on one molecule. We can have very large numbers of information processing.
When each molecule represents a bit of information, we enter a world of subatomic computers, computers smaller than atoms, which leads us to amounts of information at higher numbers than we have ever imagined before. So just how many transistors will fit on a circuit?
Now let me give you an idea of how large a number that is. 500 sheets of paper is about 2.5 inches tall.
Each transistor is represented by a single sheet of paper.
If instead of having 500 sheets of paper, you had 6 times 10 to the 23rd sheets of paper, that stack of paper would reach from the Earth to the Sun. And not just once, it would reach 400 million times. The automotive industry would be one of the first commercial applications for all forms of nanotechnology. So that in 25 years, we could think of having the car have embedded electronic elements.
Now imagine nanocircuits by the billions embedded into the surface of future cars. An electronic skin, sensing its environment and detecting damage. Humans do that. When we get scratched, our skin heals itself. And because of nanotechnology, when our cars get scratched, they will also heal themselves.
Think of what it means when we can start to have machines, entire machines the size of molecules. Think of what it means for sensors.
You know, a sensor that can detect pressure, a sensor that can detect corrosion, a sensor that can detect moisture. How can a scratch be fixed by itself? You have to think about the chemistry of the coating. The coating is basically a polymer made up of a number of single chemical molecules, monomers that have been fitted together. So if there's a scratch, we can then send to the site, encapsulated, some of this chemical monomer. The signal would be for the encapsule to open itself up, let out this monomer. The monomer then can interact with the polymer that's still there, the unscratched polymer, and fill up the scratch. What that leads us then to is thinking about the coating of the automobile as a system of multi-layers, very thin layers that can do different things.
Imagine never having to visit the body shop again, whether your car is scratched, or even if you simply want to change its color.
Let's think about an automobile that could be black, for example, in the winter. When spring comes, it could flip a switch and allow the color to change from black to white. It's not only theoretically possible, it's in fact possible technically. Do we need to stop at black and white? Perhaps not.
The future will be a new landscape. You'll still be able to climb into your car, crank up the music and escape, but in a car that always knows where it is, in a car that heals itself.
The Automatrix.
The Automatrix.
The Automatrix.
The Automatrix.
The Automatrix will
be information.
Will be safe.
Will be directions.
The Automatrix will be wireless.
Will be free.
The Automatrix
will be everywhere.
Some people, when they hear the concept Automatrix, begin to shiver and they begin to fear that maybe the machines will take over. I think it's wonderful because it liberates us.
We are headed towards the Automatrix. Cars talking to cars, talking to roads, talking to traffic control centers, the worldwide vehicle web. And what that web will connect us to, above all else, is information.
We have to stop thinking about cars as merely transportation devices that take us from point A to point B, but rather think of them as being mobile information technology platforms.
Where we're headed is a world in which information is more and more embedded in the physical objects of our daily lives, in the environment, in the places that we travel through, and that creates a new role for the car.
Technically, this Automatrix is known as a telematics system, where cars communicate via digital wireless signals, much like the internet on wheels.
Information anywhere, anytime. Your files will follow you from your home to the car to your office seamlessly. That's the mantra of the future. Seamless.
The car will say, you know, my calculation tells me you're going to be late for your first meeting today. How about I place a phone call and let the people that you're meeting with know? And in fact, the car itself could talk to these people.
It would probably say, take me to the grocery store, nearest grocery store. And it would do it.
If I come to my destination well-rested, I don't have to plan for that. If I come into a new city and I can immediately know where to park my car, if I come into a new city and I know where my hotel is, where the restaurant I'm looking for is, there's enormous time savings and improvement in efficiency and really in quality of life if all those things are possible.
Today, we sit down at our computers to surf the net, to look something up, or to communicate with other people online. In the future, because our cars will have their own brains, they will also be able to surf, search, and chat online.
The environment is becoming increasingly embedded with information about the history of the place that you're traveling through, who thinks that it's a cool place, who thinks that it's a crappy place.
Won't it be great for those people when their car can talk back to them?
You can imagine a municipal grid that's constantly re-recording the city as it changes. So when a pothole appears and a wheel that's intelligent runs over it, it can communicate to the car behind it, there's a pothole, avoid it. It could send that signal to the municipal grid, update all of the maps, let everyone know there's a pothole there. At some point it can get repaired.
The Auto Matrix will enable your car to talk to other cars. Think chat rooms in motion. Your car will become a forum for social networking.
By communicating with other cars, now we can communicate with people on the roads who may share similar interests to ours.
Your car becomes a matchmaker. Based on your personal profile, it locates drivers who are potential business and social contacts.
And can establish a real-time conversation while you're driving.
There's a lot of interest in the internet community about sharing music between cars when you're stuck in traffic. So why listen to a radio station when you can, browse around the music that the people in the cars around you are listening to?
It's not about how much gas you have or how much RPM anymore. It's about, I gotta go meet my friend Joe. So where's Joe on the map?
The young designers of today, like Ryan Joyce of the GM Intern Design Program, are completely at home imagining cars as entertainment and social centers.
My cocoon represents seating and driving in a new light. The actual dynamics of steering and navigating the car are going to become secondary to entertainment and communication. We have the opportunity to make the car into an extension of a movie theater.
And that's what the cocoon has become, a comfortable place, isolated from the world passing around you.
Well, we're delving into LCD windows, so when you are driving through Manhattan during rush hour, why not be in an island scene in Tahiti?
Though he's envisioned this, it's not necessarily his idea of fun.
I enjoy driving way too much to ever want to completely give up the freedom and the passion.
It's fun to drive a car, so we're not talking about taking control away from you if you don't want it to be taken away. We're talking about providing you with an assist, and computers are going to be underlying all of that.
Think of the Auto Matrix as optional. Beyond the considerations of safety and congestion, the Auto Matrix can be customized to whatever extent we choose. And that is because our cars play a different role in everyone's lives and will continue to do so in the future.
One of the biggest challenges for car companies is going to be managing all that information that the driver has to deal with. As car companies start to engage the media industry and the communications industry and bring those things that people want into the vehicle.
We will have the ability to shut this technology off when we feel like. The point is, we will have options. We will have the option to feel the road all by ourselves, or we'll have the option to simply read a book while we're driving on the interstate. Options. That's what it's all about.
If people are willing to experience it, if it doesn't seem too scary to them, you could have vehicles going through intersections with inches of clearance at high speeds.
It's likely we'll be traveling on the roads at 200 miles an hour.
No matter how many other vehicles are out there, traffic jams will become a thing of the past. 2030, the world will have 1.6 billion drivers. Will highways and cities get choked with cars? Will we get stuck in the ultimate traffic jam? Not if we can communicate car to car, car to roadway, car to the network. Not if we have the auto matrix to clear up the congestion.
Traffic congestion in year 2030 is what wakes me up at night.
Frustration, road rage, people wanting to kill each other after a short period of time. There is just many things about traffic that build on you over time.
For the last 100 years, cars have reshaped what our cities look like, and we've redesigned our cities so that we can have cars, and lots of cars in them.
But as urban populations grow, it's time we reshape our cars in every way.
If we persist with current 5- and 7-seat car designs for everything, then our cities are just going to get ever more crowded and grind to a standstill.
We're going to start to see the shape of our cities change what the car looks like so that we can fit cars into those very crowded places.
We're very excited about what technology has to offer to help reduce congestion.
No simple pill will serve as the perfect urban traffic decongestant. There will be a variety of remedies, one of which will come from the father of biodesign,
the fluidity of forms.
Luigi Colani.
This thing will be the city driving machine for the future. If I do a design, I would like to have 90% nature and 10% Colani, then I'm very good. The birth-giving egg was the idea behind this extraordinary small street machine.
Imagine Kalani's eggs on city streets. More traffic moving down Main Street, but less gridlock. And Kalani's eggs will use far less energy, thanks to his fluid aerodynamics and a creative use of materials. A vehicle made of 2 plastic halves and a tiny engine the size of a shoebox.
I built it to beat the world record of consumption. There's nothing much which I haven't yet done. From aircraft to ships and submarines, I designed the most famous ladies' underwear.
There's no question Luigi Colani has done it all, setting the standard for other designers with radical leanings.
My name is Benjamin Drew, and this is Clever, my vision of personal transport of the future. Clever stands for Compact Low Emission Vehicle for Urban Transport. Bath is very congested every day of the week, even Sundays. We have cars, we have SUVs, all these vehicles, they've just got one person in. And so Clever, we're being a lot smaller and being able to fit 2 Clevers in the same space as one standard sized car or SUV, we can increase the sort of density of traffic. And these sub-cars or narrow track vehicles represent a possible solution to these problems. One of the ideas behind this project is to sort of highlight that this is a possibility for the future.
So you have one of these cars, it's smart, and then another car, the frame tilts, right? So it reduces its footprint for parking. Another car marries itself into it, interlocks. Passenger gets out, frame articulates again to compact the vehicle. This person goes away. The person comes into the new vehicle, like takes the one in the front instead of the one in the back. If you noticed, she left in a green car. The car takes on her personal presets through RFID technology, and she gets inside and she drives away.
Small cars are just the first step in avoiding the ultimate traffic jam. Step 2 is utilizing the streets differently. Driving around a major metropolis at rush hour is the ultimate game of chicken. Lots of vehicles speeding around, competing for what little space there is. But to the auto matrix, there's more space than meets the eye.
Now imagine you're in traffic and congestion, and you can have low-speed adaptive cruise control, where your car can actually be set so that the gap between you and the car in front of it is constant, and as that car creeps forward in traffic, your car automatically creeps forward in traffic.
So as the creep in front of you creeps along, so do you, but without riding the brakes. By fitting just 20% of cars with adaptive cruise control, we can eliminate excessive braking. And that's not all we can eliminate.
There's no reason why in the future you couldn't have highways that don't even have lane markings. The vehicles themselves decide whether it's going to be more optimal to have 3 lanes at this speed under these weather conditions or 4 lanes under another set of weather conditions.
When you look at traffic from above, you realize that cars have a lot of empty space between them.
There's no reason why we can't travel at higher rates of speed, packed closer together.
Now imagine looking down with cars passing through at much higher rates of speed but not crashing with each other because we're able to control and know precisely where each car is relative to every other car.
Vehicles will be able to tell each other, hey, could you please get out of my way? I need to get through here, or be careful, you're getting too close to me, or this intersection is very congested right now, please be extra careful as you come through it.
It's likely we'll be traveling on the roads at 200 miles an hour.
If people are willing to experience it, if it doesn't seem too scary to them, you could have vehicles going through intersections with inches of clearance at high speed.
If we're to avoid a bumper-to-bumper world, there have to be people and machines looking at the big picture.
The next major step will be the availability of real-time information fed to the driver's telematics system so that if there's incidents on the road, they can be automatically rerouted.
At the basic level, this smart corridor is smart infrastructure that would enable the motorists, the traffic engineers, and now going forward, the vehicles. How? A vehicle that is smart would be able to interact with the smart corridor via sensors that are embedded at a strategic location along the corridor that could talk to the vehicle, discuss condition of the roadway. Imagine an urban area that has series of smart corridors that are all talking to each other.
A world without congestion sounds great, but there's no such thing as a free ride. If you want to get somewhere faster than everyone else, it's going to cost you.
If you're in a particular hurry, your car may be able to say to cars around you, please get out of my way. I'm willing to pay you to let me through here.
Imagine you're racing to the hospital. Your wife is about to have a baby. Because your car can talk to cars ahead of you, it will make the arrangements to speed you through traffic using your credit card to pave the way. Wouldn't you pay to get her there on time? When cars are interconnected through the auto matrix, they will react to danger much faster than we could, leaving our worst fears in the dust. But we're still a long way from taking the human element out of driving.
In the auto industry, we don't like to use the word accident. Accident sounds like it's not our fault. It really is a crash. It's not an accident. And crashes we can eliminate.
As the DNA of cars changes from mechanically controlled machines to digital computation, will car crashes come to an end? Will computers help us prevent tragedy on the roadway?
Human beings are very good at doing complex tasks, but they're maybe not so good at doing simple tasks over and over again. And what I mean by that is that driving is a task that is very routine for the most part. It is so safe that people can actually become bored or become disengaged from the driving task. But the great thing about computers, about artificial systems that can help you drive, is that they never get distracted. They never get tired.
Yet we all do know that humans make mistakes.
In research on driving these days, you hear a lot about HMI, or the human-machine interface. The reason that's so important now is that cars are becoming much more active in driving than they used to be. The car is beginning to become almost a co-driver with the human driver. And at one end of that, of course, would be automatic driving, cars that literally drive themselves. And at some point, I have no doubt that it will be possible to do much better than all human drivers.
Most people think of themselves as great drivers, but we need to face facts. The numbers are not on our side.
The number of people who are killed every year in the United States in highway traffic accidents is nearly equivalent to 2 fully loaded 747s crashing every week.
That's 45,000 Americans every year. Traffic accidents rank 10th as the cause of mortality on the planet. And digital technology can make it all go away.
Vision, my goal is to basically incorporate technologies into future automobiles such that as an end goal, the number of fatalities from accidents goes down to 0. That's the headline that I would like to see.
My name is Francis Memley, and I'm going to give you my thoughts on the future of automotive safety technology. 42% of all fatalities can be linked to the vehicle leaving the road, either due to drowsiness, distraction, or just not paying attention.
Government testing has shown that lane departure warning systems reduce traffic accidents on the order of 70%.
What this system does is help me. What it's doing is it's constantly looking at the roadway. We're looking for the lane marks. And from that, we find the lane marks, we classify the lane marks, and we feed that back into an algorithm that keeps track of precisely where the vehicle is, vehicle tires, relative to those lane marks. And as you drive, if you start to drift to one of the lane marks and you don't have your turn signal on, our system will give you a warning, just like a rumble strip. It's constantly looking out the roadway. It never takes its eyes off the road. It's always alert 24 hours a day, no matter what the lighting conditions are, no matter what the weather conditions are. It helps you all the time.
Today, lane departure warning systems are becoming more prevalent in tractor trailers. And in the very near future, your car will know when it's crossing the line.
By the year 2030, we certainly can imagine automobiles that don't crash. And today, we have technologies that are clearly on the roadmap to that future. Collision avoidance systems, for example. We have sensors based on radar or LiDAR sensors that actually can detect whether there's an object up the road and give our drivers heads up or advance notice that there's an object coming. Not only can computers allow vehicles to essentially see and sense what's around them, but can process that information very quickly.
There is no question that there will be artificial vision of some form in vehicles in the future.
In order to achieve a crash-free world, our cars must be communicating with one another, all guided by the smart roadways they travel on. Already, there are telematic highways in Wales, and sensors are being used on roadways in smart corridors of Southern California.
Cars will be communicating their locations within a precision of less than a meter and being able to communicate within milliseconds.
What makes engineers believe that they can achieve this mathematical precision with cars?
Think today about subway stations. It's always amazing to me to watch that crowd of people walking very fast toward each other but never bumping into each other. So we know that the algorithms exist, the controls exist in our mind to allow us to avoid those kinds of crashes. Now imagine an intersection with cars approaching the intersection from all directions. Can we take that same logic and incorporate it into the driving task autonomously?
These intuitive algorithms are being tested among small fleets today, where 2 or 3 cars successfully communicate and keep track of one another. The next step, a global network.
Let's look ahead 15 years. This kind of networking technology will be common in all cars.
Before computer-aided systems are put out on the roadways, extensive simulations are done, like testing the reaction time of machines versus humans.
This demo is a good example of how technology can help a driver. The driver hit the brake 1.3 seconds after the computer. That time difference of a second or more could be the difference between having an accident or not having an accident.
What happens in virtual simulations will ultimately make its way into our cars, and the driving experience will expand as computers show drivers far more than just what their eyes can see.
Here is a next generation technology which, while you're driving, superimposes video on the windshield. So as you're driving, you get to see artificial lines showing the lane in which you're driving. And you see that the left turn arrow was superimposed. The technology that you see here is available today. It would take about 5 years for it to be in vehicles that you can buy.
The death toll on the highways could become a thing of the past. Some quaint thing we look back and say, how did we tolerate that?
As cars get more brain power, as they become more connected inside the auto matrix, we'll approach a time when we will no longer share the work of driving with them. We will give it all to them. We will begin to view them as creatures who work for us, as robots.
The robot will not be distracted. So it's a servant that has to do what you want.
Not surprisingly, the word robot comes from the Czech word meaning worker.
They never bellyache and they never go on strike.
So when your garage is full of robots,
you won't even have to tell the vehicle where you want to go. You'll simply go in and say, let's go. And the vehicle will know where to go.
the time of cars as robots is in many ways already here. The autonomous cars that are being developed by Red Whitaker and Chris Urmson for the DARPA Challenge give us a glimpse of driving without our hands on the wheel.
The screen here is control we have to turn the vehicle basically into a robot.
This machine's computing is somewhere between that of a mouse and a monkey, and in the far decades to come might approach that of a human.
Robots are not unique in the automotive industry. They already work around the clock building the cars that will end up in your garage. And as you drive to work tomorrow, keep an eye out for robotic highway helpers.
Robots in my mind. There are several advantages to using robotic safety barrels. First, it's a very time-consuming task to deploy and retrieve and build a safe work zone for the workers. Robots in my mind. The second big issue is it's a dangerous job to move these barrels into place at the beginning and at the end of each workday. If we can automate that process, it will be cheaper, faster, and more safe. Robots in my mind.
To accomplish this, Dr. Ferreter has built sheep barrels and shepherd barrels.
The shepherd makes high-level commands. What should the group do? How should the group behave? It tells the sheep, go over there, I want you over here. In the future, I can imagine a couple shepherds being in charge of a few hundred barrel robots and moving up and down the row of robots, sort of unzipping the work zone. And then at the end of the day, bringing all those robots back into a safe location. This is a typical barrel robot. It has two wheels that are powered. In the back is a caster, just like on a grocery cart, that can move in any direction. And inside is a computer and electronics, as well as a communication system that's wireless Ethernet, 802.11, just like in your home.
I think that in the future, many cars will essentially be robots, because robots are really better suited to a task like driving, which, let's face it, for the most part, driving is very boring.
That's why we fall asleep at the wheel.
But computers never get tired or distracted.
If they're designed properly, they're always perfectly attentive to the factors that matter in order to keep you safe while on the road.
Today, robots build your car. Robots fix the roads. And though they may not be in the driver's seat yet, there are robots in your car right now.
ABS, the automatic braking system, when you apply the brakes, it starts to pulsate if it encounters slippery conditions. Now that's helpful, but you didn't do it.
Thank you, robot. And already, backup obstacle collision warning systems let you know when there's an obstacle behind you. Thanks again, robot.
You will see more and more of the driving functions being taken over by the automobile until eventually, yes, it will be possible to simply tell the vehicle where you want to go and it'll take you there. Wouldn't you feel safer knowing that the other vehicles are being controlled by systems that have been tested for reliability, that are never drowsy, that are never intoxicated, that are never talking on the cell phone when they shouldn't be?
Robot cars, acting for us. Doing the big things, doing the little things. Like cars that already park themselves.
Think of a car with radar based inside the fenders, such that you can triangulate exactly how much room you have to park. The computer chips then take over the steering wheel and park the car for you.
Just imagine what they'll do next. The time is coming when driving will be fully autonomous, a job assigned to our robots. Robot cars will be so safe and efficient that Bo Park, a young GM design intern, can imagine a time when we even trust our children to them.
My vehicle is only for one person, kids aged between 8 and 14 who cannot drive.
If you don't have the time to drive the kids to school, why not let the robot do it? Bo's nanny car is just one of the unique possibilities that autonomous vehicles will offer us.
We'll get out of the home, into the car. The car will pretty much drive itself, park itself, analyze traffic anomalies all by itself. And on the windshield, you'll be able to enjoy movies, the internet. Anything you can do at home, you can do in your car.
You're going to be driving so fast that it would probably make you panic if you saw it. So they'll black that out, and the inside of your windscreen will become your computer terminal.
The car as kind of a robot, a car making choices on our behalves, protecting us from danger.
So future cars will drive by themselves. Some do already. And if Moore's Law has taught us anything, your car is right behind.
It is not a trivial problem to come up with the first artificial driver, the first robot driver that will be able to see the road ahead and react to it as well or better than a human driver. But once you have one of those, you can make them in multiple copies very rapidly.
Digital technology is catapulting us and our cars into a completely new automotive landscape. One where our cars will let us know when we need to wake up or calm down. One where hundreds of radio frequencies will operate simultaneously and seamlessly. It will be a world where our cars will heal themselves, communicate to other cars around them, and even, as we have dreamed of for so long, get us there safely without any help from us.
I'm very excited about the future of cars because I think that what will happen 20 or 30 years from now is essentially unimaginable today.